So double linked list. So we know that. Am I audible?
Yes, sir.
Okay. So double linked list, there are always two pointers. Okay. So one is previous pointer for pointing to the previous node, and another is the next pointer which points to the next node. Okay. So this is your data part, and this is your next pointer, and this is your previous pointer. Okay. So that's why this particular list is called two-way list. Why this is two-way list? Because so double linked list. Double linked list. So these double linked lists are called the two-way list because of traversing the whole list in any two direction, either in forward direction or in backward direction. Okay. So as in case of double linked list, there are three parts. Okay. So first part is the middle part is the data part. Okay. So first part is a pointer part which points to the previous node, and third part is the next part which points to the last node. Okay. So how to write the how to write the node structure? Any idea how to write the node structure? So node is the name, struct node. So struct node. The first part, what is the first part? Your first part is the previous pointer. Okay. So previous pointer. What is the second part? The data part. And third part is the next part. Okay. So there are two pointers, previous pointer and the next pointer. Both are of type struct node. Struct node. Why struct node? The return type, data type, struct node. Any idea? Int data. So this is the node structure for DLL. So this is the node structure. Node structure for double linked list. Okay.
So
why?
previous struct node আর প্রথমে লিখতে হবে আর নেক্সটটা পরে লিখতে হবে, এরকম কিছু ব্যাপার আছে?
Yes. This is the actual order. So first one is the previous. So this is the first one. So first one is the previous. So what is the next? Next is the data. Next is the data part, and this is the final part. You have to write this maintaining a particular sequence. Okay. So this is the node structure for DLL, but for node structure for CLL and SLL are same. There are only two fields. First one is the data field, int data, and second one is the pointer field, next pointer. So why struct node? The return type of both pointers are struct node, just because of its self-referencing structure. Okay. As the DLL or any linked list are of self-referencing data structure which points to a node which is of same type, that's why these pointers are of return types are struct node. Up to this, is it fine? So in double linked list, we have to know the insert and delete. Okay.
सर एक बार
So-
और बताइए ना, स्ट्रक्ट नोड किस लिए होता है?
Is struct node, na? So why the return type of the return type? The return type of this middle field, that is data, is int, because this contains the integer part. Okay. You can also put this as char, float, anything you wish. But why this particular struct node just before of previous and next? Because these two pointers point to a node in both direction, either in forward direction using this previous one and backward direction using this next one. Okay.
Yes, sir.
So this pointer points to a node which is of same type, which is of same types. as the self-referencing structure of your linked list, we have to use struct node as the return type, as the data type. Okay.
Yes, sir. Yes, sir. Understood.
So insert and delete. We have to know insert and delete. So insert and delete. So first one, we have to know before. Sorry, beginning. Beginning, and second one is the ending, and any at any position. Okay. So similarly, delete. So this is the insert and this is the delete. Insert a node and delete a node from the DLL. So insert a node at the beginning. Let one second. One. Second node, this is second node, and let this is your third node. Okay. Let this double linked list contains 3 nodes. Okay, 1, 2, 3. These are the data fields. Now, what will be the next field? What will be the next field of the last node? This will be null. Similarly, the previous field of the first node is null. Okay, and next field of the first node pointing to the second node. Similarly, previous field pointing to the previous field of the second node pointing to the first node, and from 2 to 3, and from 3 to 2. So this is the DLL structure, and there is a start. Let this start is pointing to the first node. Okay. Now you have to insert. Now you have to insert a node. You have to insert a node. Let the node is 4. You have to insert this 4 just at the beginning of the list. Okay. So what should we do? Any idea?
So we can take the reference of the head node.
Yes.
Then the new node, we have to initialize the new node. The previous pointer would be set to null, and the next pointer would be set to the first node, and the first node's previous pointer would refer to the new node.
No, the next field of the new node. The previous null is this previous null is pointing to the next of the new node.
Sir, if it's pointing to the next of the new node, then wouldn't it?
Okay, so this is fine. So first you have to establish a connection between this 4 and 1. Okay. So first, yes.
Sir, if 4 is my new node, then start of previous will be my new node.
Yes.
Sir, so that will be the first step, na? Star of previous equals to new node.
So start of previous. So you have to delete this one. So initially this start is pointing to the previous part, the first node. So first operation is this one. Okay. So previous part of the start is pointing to the newly created node. What will be the second operation?
Sir, new node next part will be start.
So new node next part is pointing to the start. So this will be your second operation. What will be the third operation?
Sir, new node previous part will be null.
So previous part of the newly created node is made null. What will be the fourth operation?
Start will become a new node.
So cross the start. So cross the start and start now becomes, so this is your fourth operation. So there are total fourth operation for insertion a particular node at the beginning of a linked list, double linked list. So beginning, at beginning. So what will be the insert beginning? So let insert beginning dot node insert beginning, and we are dealing with the head node, that is start node. Okay. So first of all, we have to create the new node. So that's why we have to declare this one, return type struct node. So let your value is, the value is n, and int f enter your data. Enter your data. So data is at stored at, sorry, enter the data is stored at the variable in. So data is stored here in. Now we have to dynamically create the new node. That's why we have to use the malloc. We have to use the malloc. So first one is the cast type. So cast type struct node and star. And this is the byte size. So using the size of operator struct node. Dynamically the new node is created. Now this particular n is inserted at the middle field. So new node data. So new node data is equal to your n.
Sir,
Yes.
sir, we can directly put it in the scanf part, na? Like
Yes,
new
yes,
node,
yes.
so we don't need those two extra lines.
But in some cases there may be some error. In some cases you can also use enter your data and ampersand sorry, new node data. That is also fine. But in some compilers you may encounter some problems. That's why it's better to use a temporary variable in. Okay.
Yes, sir.
Now what is the operation? So first operation is the made a connection between, so this is our first operation. This is our first operation. So made a connection from previous part. So initially this was the start, previous part of the start to the new node. Okay. So start your previous new node, and the new node second operation. What is the second operation? The second operation was the new node next is now pointing to the start. Okay. So new node next. Is it clear to you? New node next is equal to start. And what is the third operation? The previous, this is the third operation. What is the third? Actually, this was the third operation. Okay. So previous part of the new node is made null. So new node previous is equal to made null. Okay. And finally, your new node becomes the start. So this newly created node now becomes your head or start. That's why you have to put start is equal to new node. Okay. And finally, return your start. Up to this, any problem? Insert at beginning.
Sir, we can also put one more clause, like we don't need to go through the extra steps. If we put it like if the start node or the head node is null, then we will directly assign that node to head, and then we don't need to go through these statements.
So how can we modify your program?
Sir, after putting new node is equal to n, then before doing all these four steps, then before that we'll put a if clause. Like if start or head is equal to null, then head is equal to temp, or in this case,
A particular program can be modified in several ways, but your logic should be correct. Okay, you can modify in your own way. Is it fine?
Okay, sir.
So this is your first step. So this is your first step. First. And this is your second step. This is your third step. Finally, this is your fourth step. So fourth step is this. It is made bold. Third step. This is the second step. Okay. So this is the insert at the beginning. Now insert at end. So insert at end. You have to insert a particular node. So now your node now becomes 4, 1, 2, 3. Now insert 5. Now insert 5 after the last node. So 5 is there. Insert 5 after the third node. So what will be the logic? How to insert this node with data 5 at the last one? Any idea? Here we have to traverse.
So
first we
traverse the loop to get till the last node.
Yes. Then the next
Sir,
part.
Then
yes. Then the next
PTR.
part. Yes, carry on.
So the next part of PTR will be new node.
So this will be your new node. So number 1. Next.
Then the previous part of new node will be PTR.
Oh. Just 1 second. This will be your second operation. And third?
The next part of new node will be null.
So this is your final operation. Okay. Now, how can we modify this one? So just copy. So insert end. Insert end. So we have to dynamically create a new node. So up to this, both codes are same. Enter your data. The data is stored at a temporary location, and n is now inserted at the data part of the newly. Yes.
Sir, apart from new node, will also need a PTR node, one more node.
Yes. You have to traverse, na?
हाँ sir, तो struct node star new node comma star
PTR.
PTR also.
Okay. Thank you. So PTR is another node. Sorry, PTR is another pointer that is used for traversing, that is used for scanning the number of nodes until and unless you are at the last one. Okay. So up to this, n is inserted at the data part of the new node. Okay. Now your PTR is your PTR must be at the this PTR must be at the first node. So this PTR must point to the 4. So PTR is equal to start. Okay. This is the initialization of your PTR. Now you have to traverse up to the last node. So while your data part, as this is the double linked list, so while your data part, sorry, while your next part of the temporary pointer is not equals to null, you have to traverse. So for traversing, we are using the PTR is equal to PTR next. PTR is equal to PTR next. So after the completion of this while, you are at the last one. Okay. Now, what is the first one? So next part of the PTR. So PTR is now at here. Okay. So next part of the PTR is now pointing to the new node. So next part of the PTR. So PTR next. PTR next is equal to your new node. And what will be the second operation? Previous part of the, so this is the second operation. Previous part of the newly created node, that is this one, is pointing to the PTR. Okay. So new node previous. So new node previous is equal to now pointing to your last node PTR. Okay. And the third operation, obviously, as this is the double linked list, not circular. So new node next. For circular, the new node next is start. But for DLL and SLL, the last node's next pointer is made null and return start. Okay. So this is the insert end. Is it fine?
স্যার আমরা স্টার্টটা কেন রিটার্ন করলাম লাস্টে?
এই যে তুমি আর্গুমেন্ট পাস করছো স্টার্ট নোট,
আচ্ছা
আর্গুমেন্টটা দিলে এটাকে তুমি রিটার্ন করছো। ওকে, নাও ইনসার্ট at any position. Any idea? Insert at any position? At any position.
Sir, it
so
would be either data based or a position based.
yes, it would be either database or position based. So 4 1 4 1 2 3 5 4 1 2 3
We
5.
need to traverse using the PTR value, using the
Okay.
PTR pointer,
Okay.
and we will check if it is a position based, we will check we'll traverse up to that until the PTR pointer reaches up to that position. And
Yes.
in
Or
that
if
and
it is
have-
value based,
sir, if it is value based, sir, means value based in the sense, sir, we are given a value and where we need to insert it, both are given.
there will be no duplicate data.
Sir, actually, value-based insertion would be problematic because there can
may
be
duplicate data. There may be
same
duplicate data.
but for two different instances.
Yes. So how can we modify? So insert position. Insert position. How can we modify? Any idea?
So the head node will point to the next, and that will be equal to the pointer node and the pointer node pointing towards next. First statement.
So I am showing the let after using value based, but in your program you have to modify using position based. Okay, this is your task. You have to
পজিশন
modify.
বেস হলে কি কোন একটা কাউন্ট ধরতে হবে, তারপরে কাউন্টটা
Yes,
ততবার লুপ হবে?
একটা কাউন্ট ধরে তুমি তত পর্যন্ত তুমি অ্যাডভান্স হবে। আমি ভ্যালু বেসড দেখাচ্ছি, পজিশন বেসড কোড করে সাবমিট করবে। So after, let after কি হলো এটা? So struct node insert after. So this is up to this, your new node is dynamically created and n is inserted, and ptr is your first node, start node. Okay, enter printf enter the value after which we are interested for insertion. So let this is your another one, another variable. Let this is your value. So int n and int v. Now ptr, so ptr, this will be your ptr data. So this will be your ptr data, and ptr data not is equal to v. Okay, ptr data not is equal to v. Let insert between 2 and 3. Insert between 2 and 3, and let this is 6. The value is 6. Okay, so here your n is 6 and v is 3. Okay, now what should we do? The new node is dynamically created and 6 is inserted at the data part of the new node. Now is it visible? Ishan?
Yes, sir.
Okay, Ishan and Kishan both are there. Okay, could you please suggest me what to do?
Yes, sir.
Sir, কোনটাতে?
এই তো 3 আর 2 আর 3 এর 2 আর 3 এর মাঝখানে আমি ইনসার্ট করব 6. Here v is 3 and n is 6.
2
Sir,
और 3 এর মাঝখানে তো?
बीच में करे तो सर V2 होना चाहिए ना, आफ्टर
Sir,
2
2 এর নেক্সট পয়েন্টারটা 6 কে পয়েন্ট করাতে হবে, আর 3 এর প্রিভিয়াস পয়েন্টারটাকে 6 কে পয়েন্ট করাতে হবে।
2 এর নেক্সট 1 সেকেন্ড 2 এর নেক্সট কি করব?
6 কে পয়েন্ট করতে হবে। 2 আর 3 এর মাঝখানে যাবে তো?
হ্যাঁ
হ্যাঁ, 2 এর নেক্সটটাকে 6 কে পয়েন্ট করাতে হবে, আর 3 এর প্রিভিয়াসটাকে 6 কে পয়েন্ট করাতে হবে।
नो पहले नहीं सर।
ও মানে অর্ডারে বলবো কোন এটা আগে করব?
yes
ও হ্যাঁ, তাহলে 2 এর এটা করলাম, 6 এর প্রিভিয়াসটাকে 2 এর পয়েন্ট করব সেকেন্ড স্টেপ, আর নিয়ে 3 এর প্রিভিয়াসটাকে 6 কে পয়েন্ট করব, আর 6 এর নেক্সটটাকে 3 কে পয়েন্ট করব।
So total 4 operations are there. Okay. Anything else? আর কিছু করবে?
Sir, if we are inserting between 2 and 3, so shouldn't v be equal to 2 because we are writing a code for inserting after a number?
Two.
Yes, sir.
V is equal to 2. Then
सर अब ये ऑर्डर चेंज हो जाएगा ये सब का।
कैसे?
सर पहले न्यू नोड नेक्स्ट इक्वल टू पीटीआर नेक्स्ट होगा।
New node next is equal to PTR next. So your PTR, so
Is 2.
your PTR is now at
2.
position 2. Okay, so this is your PTR. Now new node next. So next part of the new node now
Yes.
pointing to the
PTR next, that is third node.
okay, and
then sir PTR next equal to new node. No sir, no,
No,
sir,
no.
no. New node next, new node next is equal to PTR next. And
new
then-
node next is equal to PTR next, and
Yes sir.
this
And
is the
then-
first operation. Okay, then
Sir. Then sir we will take the like PTR next previous, like the previous of PTR next.
okay, this will
Will
point to the
6, like new node.
okay. This is the second
And
operation.
then new node previous equal to PTR,
Okay,
and PTR next equal to new node.
PTR next is equal to new node.
Yes sir.
But if you use this one, 1, 2, 3, 4,
No sir, but sir if we use this one, then we are at the beginning we are changing PTR next to the new node, then we don't have any reference to the next node, the third node, because we are changing PTR next.
PTR next is equal to
Sir, if
New
we if we do PTR next equal to new node in the first step,
yes.
then we are losing our reference to the next node, like in the node with the value 3. We need to
Yes.
first keep the reference and update its value, then we need to change the reference.
So we have to fast this connection. This is not 2, this is not 1, this is not 4.
So please use a new diagram.
Okay,
So it's very congested.
4, 1, 2, 3, 5. Four. This is 4. 1. Two. Three, and last one is your 5. So previous is made null. This connection. Okay. So this is your start. Now, first make a connection. So this is your PTR. So first make a connection previous part of the new node, previous part of the new node with the pointer and the next part of the PTR is, sorry, next part of the new node. This is the next part of the new node. Now pointing to the this one. So this one is your actually PTR next. Okay. And then you can connect, this line. This is the third one, that is break this one. Now you have to break this one, that is this is your fourth connection. Is it visible now?
Yes, sir.
Yes, sir.
So 1, 2, 3, 4. Now we have to create the links. So for one, what will be the line? Megha, for one, operation number
Sir.
1.
Sir, new node previous equals to PTR.
Okay, so new node previous is equal to PTR. 1 second. So new node previous, new node previous is equal to PTR.
Sir, then new node next part equals to PTR next part.
So this is the second one.
Yes, sir.
New node next part. Now pointing to the PTR next part, next node. Third,
Sir, then the previous part of PTR next.
so
Equals
previous
to-
part. So previous part. So PTR. So actually the node is PTR.
Next previous.
So PTR next, its previous part.
Yes, sir.
Its previous part is now pointing to your
New node.
new node. The fourth operation.
PTR next equals to new node.
PTR next is equal to new node. So there are total 4 operations. So there are total 4 operations for insertion in between any linked list.
স্যার
Okay.
থার্ড নাম্বার স্টেপটা একটু বুঝিয়ে দিন। থার্ড নাম্বার
থার্ডে কি হলো? থার্ডে কি হলো বলো? This connection is made, that is the previous part of the 3. Previous part of the 3. The 3 means ki PTR next na. 3 is the PTR next node. This is your PTR, and what is the next node? This node is your next node, its previous part. That's why the PTR next node, its previous part. বুঝতে পেরেছো?
হ্যাঁ স্যার ক্লিয়ার।
Next node, its previous part. So next node is ptr next. Its previous part is now pointing to your new node. Is it fine up to this? Any query? Odhiraj. Odhiraj আছে তো?
ইয়েস স্যার।
ক্লিয়ার তো?
হ্যাঁ হ্যাঁ স্যার, ঠিক আছে।
এবার ডিলিট কিভাবে হয় বলো তো?
স্যার ডিলিট কোনটা, মানে একটা পার্টিকুলার নোড লাস্ট নাকি একটা যে কোনো নোড?
ফার্স্ট এডটাই বলো।
স্যার ফার্স্ট এডটা একবার ডায়াগ্রামটা যান।
হুম। দাঁড়াও এক সেকেন্ড, জল খাচ্ছিলাম।
হুম।
হ্যাঁ ফার্স্ট এডটা, হ্যাঁ এই যে গেলাম। So,
হ্যাঁ স্যার।
so your node is now 41412 635. হ্যাঁ বলো।
হ্যাঁ স্যার, তো স্যার ফার্স্টে তো আমাদের ওই যে ফার্স্ট এড যে নোটটা আছে, তো সেখানে ফার্স্টে আমাদের নাল সেট মানে আমাদের ফার্স্টের পরেরটার যে প্রিভিয়াসটা আছে সেটাকে আমাদের সেট করতে হবে টু নাল।
হুম
আর তারপরে আমাদের ওইটাকে ফ্রি করে দিতে হবে।
হুম।
এই দুটো স্টেপে হয়ে যাবে।
দুটো স্টেপে হবে কি?
হ্যাঁ মানে
ফার্স্টে তোমাকে এটাকে কপি করতে হবে। দিস এস মাস্ট বি কপিড ইন আ টেম্পোরারি ভেরিয়েবল লেট টেম্প।
হ্যাঁ হ্যাঁ হ্যাঁ, সেটা তো করবোই।
Temp, okay? Then advance this s to the next part.
স্যার তারপরে করতে পারি যে টেম্প নেক্সট প্রিভিয়াস ইজ ইকুয়াল টু নাল।
Temp
নেক্সট প্রিভিয়াস ইজ ইকুয়াল টু নাল।
তাহলে টেম্প করার কি দরকার? নেক্সট স্টার্ট করলেই তো হয়।
হ্যাঁ স্টার্ট তাহলে আমাকে সেকেন্ড নোটের থেকে করতে হবে।
না না, কিছু করতে হবে না। স্টার্ট ইজ ফার্স্ট কপিড, দেখো ডিলিট at beginning. So delete beginning, start, start node start,
হ্যাঁ হ্যাঁ স্যার, স্টার্ট মানে স্টার্ট নেক্সট প্রিভিয়াস ইজ ইকুয়াল টু নাল, তারপরে ফ্রি স্টার্ট।
একটা টেম্পোরারি ভেরিয়েবল নিলাম টেম্প, ট্রাম্প হয়ে গেল টেম্প। ট্রাম্পের অবস্থা দেখেছো তো কত ডেসপারেট।
सर अभी तो लग रहा है ट्रम्प भी टेम्पररी होने वाला है।
ট্রাম্প রোড, করোনা হয়েছে তা সত্ত্বেও দেখেছো মাস্ক কিরম করে খুলে নিয়েছে।
হুম।
ট্রাক নোট টেম্প, ট্রাক নোট টেম্প। সো টেম্প ইজ ইকুয়াল টু ইয়োর স্টার্ট। কপি করলাম। নেক্সট অ্যাডভান্স, start is equal to start
নেক্সট
advance,
হুম
advance হয়ে গেল। now this is your new start, so the next previous part of this new start is made to null, so delete this one, delete only this connection. Okay, so previous part, so start previous, so previous part is made null, and now free your
টেম্প।
your temporary variable, temporary pointer. Okay, and start. So this is the code for, so free this one. So while you are freeing this particular part, you have to cross this entire one, so cross this connection also. Okay, so free free this space. So this is the delete from beginning. What will be the delete from end? What will be the delete from end? Delete from end. Delete from end. কি করবো বলো তো delete from end?
স্যার একটা লুপ চালাতে হবে টু রিচ দ্য লাস্ট নোড।
Last node. So using the temporary start node temp. So temp is equal to start. Now
while লুপ একটা।
delete these two lines. So while your temp next not is equal to null. So you are at the last one. So temp is equal to temp arrow next. Okay. Temp arrow next. So you are now at the last one. So 5. So now temp
Sir,
is
then temp previous is equal to null.
so temp is at last position. Okay. Now কি করবো এবার?
Sir, now temp previous is equal to null.
So previous part of the temp. So this
Is
is
equal
the
to null.
previous part. So this is your previous part. Megha, is it clear?
Sir, we
Yes.
will do the next part of temp of previous. Now that will be null.
Next yes actually this. So this is your this connection, this is your previous part of the temp. So temp previous, its next part is made null.
Yes, sir.
You have to make this one as null. You have to make particular this one. What is this? This is the next part of the previous node. So previous node means temp previous. So next of temp previous, that is the temp previous and so temp previous is 3. So temp previous, here temp previous is 3. So temp previous, its next part is made null because this is the last node. Now free ptr or free temp. Okay. So this is the deletion at the end. Okay. Now delete from any position. This is your homework. Do yourself. পারবে তো নাকি? Can you do that? Ishita 9064.
Yes, sir.
So how to delete from any position?
Sir, please show the picture once.
Let the node is now 1 second. This is 1, next is 2, 1 2 6 3, 1 2 6 3. You have to delete this 6.
So first we will traverse till 2
Traverse till 2. Okay, so this is your ptr.
PTR.
Next.
Then 1 minute, sir. No, sir, we will traverse till 6.
Traverse till 6. Okay, 6.
Yes, sir.
Traverse till 6.
Then the next of one second, sir. Yeah, the next of 6, the previous of the next of the 6 will be equals to the previous of this PTR, which is at 6.
Yes, and
And the next of the previous of 6 would be equals to the previous of the next of 6.
that is basically made a new connection from 2 to 3
Yeah.
so that you can omit these 6.
Hmm.
এটা কি করে দিতে হবে না পারবে?
So I can do that.
ওকে, বাকিরা?
Yes, sir.
Yes, sir.
জয়ব্রত 9067, জয়ব্রত ইয়েস স্যার বলেছে। পারবে না করতে হবে? আমার মনে হয় পেরে যাবে। ওকে, so this is your entire DLL double linked list. So double linked list, we have to insert at beginning, insert at end. In your main final exam, final written exam also, you can asked to write insert, write down the function for insertion at the end in DLL. Then you have to write this particular code, or you can also write the algorithm, but the diagram is mandatory. Along with the diagram, you have to explain. That is basically you have to explain the operations 1, 2, 3, 4, 4 operations. You have to explain very clearly. Okay, then only you can get the full marks, 5 out of 5. Okay, so at any position, this is at any position, and delete a node from beginning, delete a node from the end. Okay, and delete from any position. This is your homework. Okay, now we have to go through the stack. Start করছি stack, দেবাশিস দা।
হ্যাঁ বলো।
স্ট্যাক স্টার্ট করি আজকে নাকি?
হ্যাঁ 4টে বাজে, স্টার্ট করে দাও। অল্প কিছুক্ষণ তো লাগবে।
হ্যাঁ, স্ট্যাকে তো খুব একটা বেশি লাগবে না।
হ্যাঁ
উইদিন 30 মিনিটসের মধ্যে স্ট্যাক আশা করি হয়ে যাবে।
হ্যাঁ স্টার্ট করে দাও।
सर लिंक लिस्ट में एक डाउट था।
हाँ 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 बोलो
सर एक्चुअली जब हम लोग स्ट्रक्ट किए थे सी में, स्ट्रक्चर एंड यूनियन,
हाँ।
तो हम लोग को मतलब ऐसा ही था कि स्ट्रक्चर में मतलब जैसे हम लोग स्ट्रक्ट नोड बना रहे हैं।
আচ্ছা কিষান, কিষান এই ক্লাসটা শেষ হওয়ার পর তোমারটা শুনি।
ठीक है।
ওকে, থ্যাংক ইউ। সো স্ট্রাক্ট stack, what is stack? One second, we have to create paint, new paint. So we know that stack is nothing but a last in first out structure. Okay, last in first out data structure, stack. So we know that what is the push, what is the pop. What is push? Push is the insert. For insertion we have to use this push function. Okay, and what is pop? Pop will return the topmost element. It will delete the topmost element from the stack. Okay, now let just one question. Let the following sequence of operations are performed on a stack: push, let push 10, push 20, Then you call a pop. Then again push 10. Next push 20. It is followed by 3 pop. Next you push 20. Next pop. So this is the sequence of operations. So first two push followed by 1 pop, then it is followed by 2 push, followed by 3 pop, and 1 push and 1 pop. Now, what will be the sequence of values popped out? Any idea? What will be the sequence of values popped out? What will be the answer?
20, 20, 10, 10, 20.
This is from GATE question. 20, 20,
20, 20, 10, 10, 20.
20, 20, 10, 10, 20. Let us check. So first one is so you have to initialize. So you have to initialize a top pointer. So what is top? Top is nothing but a start or head in case of linked list. Okay. So top is equal to here. Top is equal to initialize. Top is equal to -1. Okay. Now we have to implement this stack using array as well as using the linked list. Okay. So first we have to implement this stack using array. So this is 0, this is 1, array index. So this is your 2 and this is 3. Okay. So first when you are inserting a element, that is push an element. So what will be the first operation? The first operation is to increment your top by 1. Okay. So that a new room is created for the new entry. So first you have to, when you are pushing a particular value, so you have to insert. So you have to increase this top by 1. Okay. Now what is the value? The value is push 10. So 10 is inserted. Okay. Next, again push 20. So we have to again increase this top by 1. Then insert. So 20. Next pop. So you have to delete. So for deletion, first delete the item. So first delete the item 20. Next decrement the top. So your top now becomes pointing to the 10. Next value is push 10. So again you have to, so just clear this one. Now push 10. Okay. So you have to increment the top again and push 10. Next is push 20. So again you have to increment this top by 1. It is pointing to the 2 and insert 20. This is the last in first out data structure. Okay. Only one open end is there. This is the open end. Only one open end is there. So push 20. Next is 3 times pop. So 3 times pop. So for 3 times pop, first delete every items, then immediately decrement the top by 1. So after calling the 3 pops, your stack is totally empty. Okay, fine. So this is your stack. The stack is totally empty. So 20, 10, 10. So 20, 10, and 10. These are the values. The last entry was 20, 20 was popped first. That's why last in, first out. Next entry was 10, next 10, and the last entry was 10. It is popped out. Next, push 20. So again, you have to increment this top and push 20. Okay. And finally, pop. So delete this one and 20. So 20, 20, 10, 10, 20. So this is the final answer. Okay. Now, we have to create this stack using array and linked list. Okay. Using array and linked list. So using array, using single linked list, linked list. So how to design this stack using array? What will be the push function? So let the push function is int push. So let
Sir, it should be void push na, because what will the push function return?
okay, void push. Let you are using the stack. You are using the array. Let the name is stack, and your value is n. Inserted value is n. So you have to declare this one. So int. So int stack. Let this is macro definition as defined max n. And your value is n. Again, here top is your head or start. So top is initialized with always -1. So what will be the full stack condition? What will be the full stack condition? This top pointer is used. This top pointer or counter is used for advancing your movement, okay, by either 1 or decrement by 1. So the size, let the size is max. Let the size is max. Let the total stack size is max. So starting from 0, if the size is 10, if the array size is 10, starting from 0, what will be the last index? The last index will be 9. So here the last index will be max -1. Okay. So what is the condition for full stack? If, any idea? If top
Sir,
is equal to max -1. Okay. Then just write down is full stack overflow. You can't insert anything. Overflow. Otherwise, এবার কি করব বলো তো?
Sir, top plus.
So first we have to increment. This is the main idea. First we have to increment your top so that we can create a new space. Next your stack
Of top.
your stack top is equal to your n.
N.
Okay. So this is the push function. Is it clear to you? Stop. So we have to delete the last one. So int will return something, the value. So int stack. What will be the empty stack condition? What will be the empty stack condition? If what will be the condition for empty stack? Anyone?
Top equal to -1.
If top
Equal.
is equal to -1. If top is equal to -1. Okay. If top is equal to -1, then just write underflow. If top is equal to -1, then underflow. Otherwise,
Sir, return -1 also.
return.
Sir, if it is underflow, then we'll return -1 because the return type is int.
Yes, you can customize your program. Okay. So just this is the basic concept. So if your stack is totally empty, you can't delete anything. If your top is -1, then just write underflow and return -1. Okay. Now other part. So other part, you have to use a variable n. Okay. So stack array, its top position. The top position of the stack array is now stored in this n. Okay. Your next task, what is the next operation? Minus minus, decrement. Finally, return. That's why int return n. So this is the pop operation. Is it clear? Megha?
Yes, sir.
Okay. Okay. Megha is the return -1.
Ha, sir, in the yes, sir.
RET URN return -1. So you have to use the bracket as this contains 2 lines. So this is the pop function. So this is the pop function and this is the push function. Okay. So this is the push and pop. So that is implementation of your stack using the array. Now you have to implement this stack using a single linked list. কুন্তল আছে কুন্তল কুন্তল আছে
Yes, sir. Yes.
কি করে করব বলো এবার ইউজিং আ সিঙ্গেল লিংক লিস্ট
Sir, insert first beginning.
স্ট্যাক তো আবার ইনসার্ট ফার্স্ট কি বলছো স্ট্যাক ইজ ইনসার্টেড অনলি ফ্রম ওয়ান এন্ড
Linked list use করো sir.
হ্যাঁ লিংক লিস্ট ইউজ করবে কিভাবে করবে সো ফার্স্ট অফ অল your array is array name is stack and its size is 10 max. Okay, and top is equal to -1. So what will be the counterpart in case of linked list? So stack max. So stack max, here you have to create the node. So struct stack. Okay, struct stack. Now it has 2 parts. So data part and the next part. Now as this is the self-referencing, so struct stack int data. So this particular 4 lines is used for creation of your node in stack. Okay, so this is quite equivalent to stack max. Now top is equal to -1, so here top is equal to -1, top pointer. So top pointer, so you are using the top pointer, its return type. What is the return type? Its return type, as this is a self-referencing, so struct stack. And -1 here it is, you can customize with null. Okay, now push function. Let the push function and the return type, লিংক লিস্ট করতে করতে নোট বেরিয়ে যাচ্ছে। stack push, as this is the insertion sorry, as this is the insertion, so you have to deal with top. The top is analogous to the start one. Struct stack and your value int n. এবার কি করব বলো তো কিষান?
Yes, sir. Sir, first we will check if top is not null. If it is null,
First of all, you have to create the new node.
yes, sir.
So new node. So new node, define this new node.
Struct stack.
Struct stack new node and dynamically create new node is equal to malloc. So first one is the typecast. Here the typecast is struct
Struct stack.
stack.
Star.
And next one is the byte size. So
Size of
size
struct stack.
of struct stack.
Yes, sir.
Next one is the next one is the
New node
this is
next.
your, yes, this is your n is already inserted as the second argument. So new node data, not next.
New node data equal to n.
New node data is equal to n. So the value is inserted at the data part. Now, now you have to check. Now you have to check whether your stack
No,
using
sir.
stack.
Sir, we can directly use it.
1 second. So let this is your 1, 2, and 3. So from 1, 2 is there. From 2, 3 is there. This is the single linked list. So last part is made null. Okay. And this is the, this one is the array representation of your stack. So what will be the last position of the top? What will be the last position? Top will point to the last entry. Is it right? Top will point to the last entry.
Yes, sir.
Okay. In case of stack, there is only one open end and another closed end. Okay, so this is your closed end. So this will be your top. This is analogous to the start or head in case of linked list. So top is 1. Now we have to insert. Let 4. Now we have to insert this 4. We have to insert this 4 just at the beginning, means only one side insertion. Only one side insertion. So you have to insert this, that is, you have to push this 4 in the stack. So if your top is null, so Ishan jeta bolchilo, if your top is equal to null, if your top is null, that is, if your top is null means
सर इसके बिना भी हो जाएगा, बिना चेक किए भी
नहीं.
सर
If
we can
top is-
directly
one
sir, we
second.
can- हाँ सर.
1 second, you have to check whether you have to check the condition of your stack. Okay, you have to check every time. You have to check the condition of your stack. This is the
But sir,
algorithm.
इंसर्शन में हम लोग क्या चेक करेंगे?
If your top is null, that is, this is totally empty stack. This is the condition. Then your new node is only one node,
Yes,
and
sir.
new node next is null,
Yes, sir.
and top is equal to new node. This is
Yes,
just simple 3 lines. Otherwise, what should we do? Otherwise, that is, your list is, your stack is not empty. Then what should we do?
New node next equal to top.
Yes. So
And
this
top
connection.
equal to new node.
So this new node next. So this is only one connection. New node next is top, and second connection is the cross this top, and top
equal to new node.
top is equal to new node. So this is
सर
the
ये तो डायरेक्टली भी हो जाएगा बिना चेक किए. अगर टॉप नल हुआ
Yes.
भी तो न्यू नोड नेक्स्ट इक्वल टू नल अपने आप असाइन हो जाएगा.
हाँ, ये भी हो
सर
सकता है.
इसमें चेक करने का जरूरत नहीं है हम लोग को.
Okay. So if otherwise, so
डायरेक्टली न्यू नोड नेक्स्ट इक्वल टू टॉप एंड टॉप इक्वल टू न्यू नोड. बस.
new node next is equal to top, and your top is equal to new node.
And return top.
Return your top. Okay, but if you use the if and else, then you have to do this one, that is, if your top, that is totally empty, if your top is null, if your top is null, that is empty stack, then new node is the only one node, so its next part, as this is the SLL, new node next is equal to null, and new node next is equal to null, and your top is equal to new node. Okay, otherwise, so this is the two lines are from so this is the empty, so otherwise, that is, your list is not empty, so new node next is equal to top, and top is equal to new node. Okay, so this is the push function using linked list. Okay.
But sir,
Yes.
sir, during insertion, why do we need to check if the list is empty? We in
You
the
can
array
just-
one we
yes.
needed to check if it was full. We do not need to check if it is empty or not.
Yes, you
So
can do.
if it is empty, then we can insert. It doesn't matter.
If this is empty, we can't delete.
Yes,
If
sir.
it-
So why are we checking in insertion, pushing?
Okay, you can skip this one. You can also skip this one, this line, this line. Now is it fine?
Yes, sir.
New node next is equal to top and top is equal to new node. Okay.
Yes, sir.
Now how to delete? How to pop? How to pop? So pop struct tag and top. Stack. Okay. So how to delete? Any idea? কিভাবে delete করব?
Sir, we delete the first node and then change the top to the next node.
So we have to delete the
First node.
first node.
Yes, sir. So in here we need to check if the list is empty or not.
So we have to delete this first node 4. Okay. So we have to delete this 4. So this top is now pointing to that top next. Okay. So first of all, you have to use the temporary variable as deletion, that is free. That is struct tag. Now your top is pointing to your temporary variable. Okay. এবার কি করব কিষান? If
Sir, top equal to top dot.
if top equals to null, if top is equal to null,
Underflow.
printf underflow.
Yes, sir.
Otherwise we have to delete the first one.
Yes,
we have
sir.
to delete the first one. That is, first we have to copy this one in a temporary variable temp. First we have to copy this one, and second we have to advance this top, that is our start or head, to the next node. So otherwise top is equal to top next and delete that particular value. I mean, just show the value deleted is, what is the value? Temp data. And finally
Return.
temp. Okay.
Then return top.
Then return our top. So this is the linked list representation of the stack. So this is pop and this is for push. Okay.